Okay, it's 10:45 and we'll begin this morning's session. Welcome to the Fleming Room. Our first talk is going to be by Lyndon White, aka Ox in a Box, and he's going to be talking about managing your data dependencies.
Cool. Hi everyone. Am I good to go? DataDeps.jl and some other things. So before I start, I thought I should be thanking Christoph Stocker. We started talking about this idea about 2 years ago, and this code is kind of an abstraction of some stuff he wrote earlier. Also my GSOC student, Sebastian Santi, who's done a lot of the work on DataDeps.jl, and the Australian Research Council grants that allow me to actually come here and present to you today. So, Van der Waal presents 6 degrees of what he calls reproducibility, but we'd call replicability. Important part here is to be in level 4 or 5, you need to spend at most 15 minutes of user effort, that's not total time, just user time, on doing the reproduction of their results given their code. So if we want to think about how that breaks down, so I've got the paper, so maybe I spend a minute and I find the code. I have to look it up from the paper. I give a quick skim of the README, then I download the data because that's probably somewhere else. I spend 2 minutes trying to work out how to use tar or SFTP or whatever tools I need to do to get my data even onto my machine. I then spend a couple minutes trying to work out how to tell the script where the data is. So that could be editing a config file, that could be passing as a command line argument. I don't know, I have to read the README a little bit again to work that out. It allows you 2 minutes to set up any software dependencies. If it's a Julia package, hopefully that's just done, but maybe it's not. 2 minutes of babysitting the code to make sure it doesn't just crash. Assuming it doesn't crash, I come back after it's done and I got 3 minutes left to interpret the output. So 15 minutes is a pretty tight schedule to try to work in. So what we're looking at doing is cutting out that 5 minutes there that you're spending messing around with data. So this is the big picture of my talk. We're not going to cover all of this in detail, but this is kind of the ecosystem that we're working in. So the Julia packages we're going to have here are these. And we'll start by talking about DataDeps, which supports these packages and a few others that I didn't write, which is cool. And of course is useful for your research code directly. When I say data, I do mean both like tabular data or corpus data, or say a pre-trained machine learning model. More or less anything could be data. It's quite the abstract sense. I'm going to talk about DataDeps generators, which is a tool for generating code for use with DataDeps. It supports these repositories of data and several more. We're going to wrap up just by talking about CorpusLoaders.jl, which is the tool that motivated me to do this, and it's got a kind of a bit of, once you've got your data, what do you do with it next? For tabular data, that's very easy. For NLP data, it's a little harder. Code depends on data. So if you've got a package dependency in Julia, you're going to use package to get your dependency. If you've got a binary dependency, hopefully you're using binary provider. But what are you doing for your data dependencies? So you could just stick something in the README, like I said before, but then you can't use continuous integration because it's a manual install process. You could put a download command inside your build.jl, which is good for many projects, but in the embeddings.jl project, it has 500 data dependencies, and you don't really want to download all of them because a user's only going to use one of them. So we'd rather something that does lazy downloads. And you could put in the Git repo, unless it's over 50 megabytes in size, because Git won't take that. And of course, you've got 500 of them. You don't want to put 500 big binary files inside Git either. So these are options. Some of them are good. But we can probably do better, and that's what DataDeps.jl is for. So I think there are 3 key questions about data. Where am I going to put it? Am I allowed to redistribute it? And how do I ensure they get the right data so they can replicate my results? So with storage location, one of the questions I often see is, do you want to put it on your local disk, which is small but very fast? Or you put the network file store, which is slow, but it's huge. And then often you want to like move it between one place to the other, And you don't want to have to reconfigure everything to do so. So DataDeps has this notion of a load path separate to the Julia load path, which is where it goes looking for data. I'll talk about more in a bit. Second one is redistribution. So if you don't own the data, you may or may not be allowed to redistribute it. It makes you feel anxious from a legal perspective. And this is not legal advice, but in general, DataDeps work by redistributing a link to the data, which is kind of how the web works, and so you're probably allowed to redistribute links to data. The other side of that is you want to give good credit and good data provenance for who originally created the data, so that people know who to cite if they make a work based on yours and they will cite someone else's data, that kind of thing. So DataDeps.jl handles that by using a prompt, which is given to the user to say this kind of information, basically. The final point is replication. So you want them to run the same data you ran on. You don't want them to make mistakes, incorrectly extract it, waste their time with trying to find out where to download it. You want to make it all automatic so that it just happens. And you also want to be safe against corruption, modification, or updates, because that's going to change results. You want to know if someone's updated the data. So we check for that using the file hashes, and that's good, it works. So from a very high-level perspective, how do you use DataDeps? If you're a developer of a package, or you're a researcher making a research script, you write a registration block in the modules init function. I'll go into those in a bit. And then whenever you need a path, rather than writing a hard-coded path, you instead use a DataDep path, which is a string that looks something like that. Then the user, or the person trying to replicate your result, they just use the package. They run the code. The data will automatically be downloaded, they'll get the prompt, and it'll all just work. It's supposed to be very easy from the user perspective. So when you run that string macro with that, what happens is first it searches the load path for a folder with the correct name. If it finds one, then it's done. It can just return that path. If it's not found it, then it's going to display the message, get the user to agree to it if there's licensing conditions, etc. Fetch the data, check it with the checksum, assuming that passes. It'll form the post-fetch method, which could be to extract an archive or something like that. And then finally, it'll return the path. And then next time it's called, we'll just go down the thing and it'll return the already fetched result, unless it's been deleted. So I found this, after I had it set up, more convenient than I expected. So my supervisor came to me, he said, we're out of hard drive space. If you don't clear out the hard drive space, the machine's going to crash. It's going to be a massive pain. And I said, OK, I'll delete everything. Just delete all my data. I don't need it. It'll come back when I need it. And that was great. It just works. Another time, I wanted to run my work on another server. So I just cloned the project repo. I didn't have to worry about SFTPing all my data across, because I knew the data would turn up when it was required. And then another time, I accidentally modified one of my raw data files. And so I just delete all the data. And it comes back again. It's a fresh copy. It's not got my changes. It's convenient. So DataDeps.jl is aiming for the low-hanging fruit. So it's got a particular set of requirements that it expects data to have. It can kind of work without them, but it's a bit harder. So it needs the data to be static. It doesn't automatically re-download the data if it's changed. So if it's changed, you have to update the data dep and delete your local copy. That's a hard problem to even know if the data's changed on the server or not. I'd be interested if anyone has thoughts on that. It assumes the data is public. The default way of fetching the data is to just download it. It doesn't know anything about logging in and authorized. We do have workarounds and other systems to do that, which we can talk about in a bit. It assumes the data is file-based. If your data is coming from some streaming web API, then use your streaming web API. You don't need DataDeps. It's not for that. We can contrast that to Git. So Git assumes data is dynamic. Any mechanical engineer will tell you that statics is just a special case of dynamics. Git does know a bit about auth, so you can use public or private fairly easily. It's also file-based, but Git wants all your files to be plain text. It's not very happy with these binary blobs. And it also wants your files to be smaller than 50, maybe 100 megabytes. It won't accept the larger files. So the registration block is the main thing you have to provide to use the thing. So this is the one used in WordNet, which is a lexical database for English. So it's got the DataDep name, which is what you put in the string to call it, to find it. It's got the free text field, which has some info and the licensing terms, a URL to download it. This is the SHA-256. If you skip the SHA, then it will, you'll get a warning message saying, please add this SHA to the file, so you can run it the first time, and then you'll get the result, so that next time you run it, you'll expect to get the same one. And we're saying that after we do it, we want to unpack that archive. A more complicated example, in this one, we have a list of lists of files to download and 2 post-fetch methods. So identity, which will do nothing, is applied to the README, and unpack is mapped over the second element. You can kind of nest these things as much as you want for most of the fields. It also shows how we can use an MD5 rather than a SHA sum, which a lot of data, rightly or wrongly, is MD5 included. So yeah, that's kind of your registration block. If you did want to handle private data, then this is kind of how you do it. So you can override the fetch method to do whatever you want. So you could override it to use rsync, you could override it to use Google Drive. We have Google Drive prototype working, which uses your private Google Drive login. Or kind of generally, if we had an OAuth2 package for Julia, which we don't, but someone could make one, that'd be great. Please do. Then you'd just write code that looks basically just like this, and it would do the OAuth2 authentication to download the files. So yeah. Oh, we're now going to take a short break. So, and we're back. DataDeps generators. So I noticed that when I was writing like my registration blocks, I spent a lot of time just copying and pasting stuff off websites. And I thought, well, I can use the APIs to pull this data automatically. So DataDeps Generators supports a lot of these different APIs. It's many. It comes to a total of, I estimate, about 10 million different data sets are supported. A lot of those from like DOIs from DataSite. CRAN is another big one which supports things like data.gov, data.gov.au, not data.gov UK, but a lot of countries, national governments support data on that format. And we've got a bunch of them, more than just these. So yeah, we want to avoid this copy pasting to automatically generate those. So the kind of data we want is stuff like this. And the way it works is the original author, after doing some research, they're going to upload their data to, say, Figshare. And they're going to put the data up there, and they're going to give some metadata to the repository. DataDeps Generators accesses the API of the repository to fetch that metadata. Using that metadata, it generates code, just static code, which you can then include into DataDeps or into your research script, and then DataDeps.jl will resolve that and fetch the data. You might want to edit that code to like make it shorter, customize the message, whatever. So the reason we generate static code rather than just simply accessing the APIs directly is that we want to avoid DataDeps generators having these big dependencies like web scrapers and parsers. So you just end up depending only on the data. It also means you don't have to worry about the website that you're scraping going down or being inconsistent. Surprisingly, even like the DOI services aren't actually consistent. I was surprised how unstable various things are. So data generator sometimes breaks, but if it breaks, it won't break your research code because it's static files. So an example for data dryad. So that you give generate and you pass in a URL or some other ID, preferably a URL, and it's going to find out which APIs it can use by trying all of them and failing for most of them. But that's fine because we only need to succeed for enough to give us the data. So Data Dryad uses 5 different APIs will successfully resolve. Most of the DOIs resolve with like 4, some of them only do 1. Some websites, of course, won't work at all. And then using this, we merge the different results. This is really cool, and we merged the code to do this yesterday. But so if you've got something, say, on Figshare, then Figshare is going to have the URL to download the data, but it very rarely has a reference to the paper the data was about. Conversely, the DataSite API never has the URL to download the data, but it almost always has the reference to the paper describing the data. And then other things have other bits of things you'd like to stick in for good provenance information. So we're going to merge those, and we get a really nice, high-quality metadata description that we can then execute and receive the data that we wanted. Which it's really nice. It's cool. I'm pleased with how that turned out. So how are we doing for time?
We're 14 minutes in.
Oh, cool. Plenty of time. So the last part of talk, I'm just going to briefly talk about CorpusLoaders. So this is the project that got me kind of started thinking about I need more data, I need to do it more consistently. So it has a number of parts, the first of which was DataDeps, and the others I'll go into presently. They turned out to be useful for other projects as well, which is nice. So CorpusLoaders itself just has a few parsers for a few semi-standard formats used in NLP, and the registration blocks required to actually download the data in those formats. It's very similar to ML datasets. We've been talking about maybe merging it with ML datasets, but it has a few differences. One is that it always lazily loads your data from disk. So I don't want to load all of Wikipedia into like the 2 gig of RAM that my laptop has. So it does it just lazily on request. The other one is everything's multi-resolution, which I'll talk about in a bit. So the first part I needed was word tokenizers. So in NLP, you want to break up your data into words. Tabular data is easy because it's tabular data, but if you've got these words, you need to segment them. So I stole a bunch of tokenizers from NLTK, but NLTK stole them from someone else first. So all these tokenizers have just been floating around since the 80s, depending on them, and they're basically these big series of regex that describes English, or sometimes other languages, mostly English because the NLP field's quite English-centric. So what I ended up doing with them was using some metaprogramming. I made code that could generate the Julia AST from a sed script. Then I translated the Python into sed, and that was like a nice, easy way to get these tokenizers quite portably and quickly. The oldest ones are sed scripts, because that was what people did in the 80s. So that just works. Once you've tokenized your data, you've gone from having this one big bit of data to lots of small bits. You've got all these pointers, you've got all this duplicate memory in use. Since strings are immutable, we don't need to have a reference to each instance of a string when we could just reference the same one as before. So we have internstrings.jl, which can intern anything, but mostly interesting for strings, which basically helps you cut down on duplicate strings. You can call string equals internstring, which will add the string to the pool of intern strings that it knows about, and then it will return a pointer to an element from that pool. So this removes any kind of duplicate strings. And one of the nice things is it uses weak references, which means that once your last actual reference string, so interns turns a strong reference, has been garbage collected, the weak reference will also be garbage collected, deleting it from the pool. This is in contrast to symbols. So a symbol in Julia is an interned object, but they never go away. So if you're going to allocate like 1 million symbols, you're going to have like basically a giant memory leak. Whereas this, once you're done with it, it garbage collects just like normal. It's also a little bit faster for certain types of equality comparisons, that kind of thing. Anyway, and then the last bit, which is a thing that, I don't know if this occurs outside of NLP. I'd like to hear if anyone else has this kind of problem, but the kind of data you get, you've got a corpus, say Wikipedia. That's made up of, say, documents, Wikipedia pages, each of which has many paragraphs, each of which has many sentences, each of which has many words, each of which has many letters. And different people want different parts of a corpus. So a corpus linguist trying to understand how language is being used, they're probably interested in just sentences made up of words. They don't really care about the documents often. Sometimes they do. Whereas someone doing information retrieval, they want to just know what words we use to documents so they can look for documents that have a good word overlap with your search term. Whereas someone doing, say, a character RNN, and they're trying to train a supervised model to predict what a document is about, they just want the documents and a stream of letters. So different people have different wants. So multi-resolution iterators exist to solve this bit. So here is some information about animals, which you can get out of calling the tokenizer a few times on, say, the wiki corpus. So this is an array of strings. So that's documents made of sentences, made of words, made of characters. So we've got this level name map that we define, and that's going to let us refer to the levels by either name or by number. If you don't define a level map, you can just refer them by number. So multi-resolution iterators exposes functions like this. So you can say that I'm trying to get my documents made up of words. So I want to flatten out level 2, or you can say I want to flatten out the sentences to remove those, or you can say I want to flatten out everything except for the documents and the words. And that will let us get something like this. So we don't have all that excess structure that we don't care about. So yeah, to wrap this up, data, it's important. It's basically the basis of all our research code in a lot of fields, especially data science, machine learning. We have a lot of these benchmark data sets we like to use. You can use DataDeps.jl to simplify your data management, whether that's downloading your CSVs, or it's downloading a pre-trained machine learning model, or whatever it is. And if you want to use someone else's data, or data that you've already put on, say, Figshare, Data Dryad, etc., you can use DataDeps generators to generate the code blocks so you don't have to write the rest yourself, and you get very nice provenance information. NLP is one area where we use a lot of data, and we have some packages that make NLP-shaped data kind of work well. So yeah, that's where we're at.
Thank you, Lyndon, and we'll take any questions. We have about a little over 5 minutes for that. So, yeah, great. I'll bring the microphone to you when you raise your hand.
You mentioned mostly reproducing research as an example for DataDeps. What about running test suites on packages and pulling in data to run your tests? Is that also a good use case for DataDeps?
Yeah, I think it's a very good use case. So that's how we're using it in what's it, WordNet? Okay. In WordNet pool is a package. It depends on the data to be able to explain what is a synonym, what is an antonym. And so yeah, it pulls in that data automatically, and you can use that to run the tests. Yeah, sometimes you can't because the data's say too big to run on GitHub, but most of the time you can, not GitHub, Travis, but yeah, it's useful for tests.
Anybody else have a question? So I was curious about how the multi-resolution indexers handles, it seemed like you just flattened it right away. You were only keeping 2 levels.
Yep.
What about actually lots of levels and adding new kind of intermediate levels between those? I might care about something that's between a sentence and a document, like a phrase, or a sentence and a word.
Yeah, I haven't thought too much about adding new levels. I don't know if that'd work out. I'm not sure. It'd be interesting. The code's fairly simple once you get into it. It's basically describing a way of applying iterator functions onto levels. What was the first part of the question, sorry?
If I wanted to keep around multiple levels, and then if I wanted to add a new kind of custom level, like between sentence and word, there's phrase or something.
Yeah, we have. It's right now we've got a few other things for that kind of thing. Like you can completely get rid of levels, but nothing for adding levels at the moment. PRs are welcome.
Okay.
So is it doing it Is it doing that lazily or?
Yes, normally.
Normally. So the consolidate was when you made a copy,
so
I guess.
Consolidate is a generalization of collect.
Yeah. Yep.
A collect says certain statements about that I'm going to end up with an array.
Yep.
Consolidate, you can consolidate, you see I ended up with a string.
Yep.
You can also override it to do it eagerly, but it depends what you want.
Yep.
Yeah, because there's a functionality code which you overload the apply function, and then it will. You can make it do whatever you want, basically.
Okay. Thank you.
Great. Are there any last questions? Then we'll thank the speaker again.
Oh, I should mention.